So here to find our equivalent, we will have to consider any two of these resistors in series, and the third one will then be in parallel with that series combination. So if we consider R1 and R2 in series with each other, then R3 will be considered as in parallel combination with this series combination. Like this R12 is the equivalent resistance for the series combination of R1 and R2. We have considered R1 and R2 to be in series, so their equivalent is equal to the sum of R1 plus R2, and it is represented by R12 over here. Now the third resistance R3 will be considered to be parallel with this series combination. So the equivalent resistance for this parallel combination will now be equal to 1 over R equivalent is equal to 1 over R12 plus 1 over R3. So solving this thing, we will get the LCM as R12, R3, product of these two, and in the numerator we will get the sum of these two. So here we have R3, and R12 is actually the sum of R1 and R2, like this. And again R12 will be written as the sum of R1 plus R2 multiplied by R3. So opening the bracket, we get R1 R3 plus R2 R3 like this, and here we have R1 plus R2 plus R3. So we have to find the R equivalent, so we will reciprocate both sides of this equation. The left hand side, when reciprocated, will be equal to R equivalent, and the right hand side, when it is reciprocated, will be equal to this. The denominator will become the numerator, and the numerator will become the denominator. So this formula will give you the equivalent resistance of such combination, which is in form of a triangle.